Thank you very much. Greetings to our attendees. Thank you for joining us today. My name is Eric Henderson. I'm with the marketing team at Modular Mining Systems. Today's webinar is entitled, How's Your Health? How MineCare Standalone can give you the tools and data to solve your equipment health woes. Our presenter today is Justin Johnson, Product Manager for Maintenance Systems and Interfaces at Modular Mining. For those of you who don't know him, Justin holds a bachelor's in mechanical engineering technology from Old Dominion University in Norfolk, Virginia. He has over 15 years experience in the realm of heavy equipment maintenance and mine asset health management via the U.S. Navy and 3 large open pit copper mines in Arizona. Before we get started, a couple logistical items. The first, I'd like to remind everyone that the content of this webinar is copyrighted by Modular Mining Systems Incorporated. Secondly, we'd like to encourage you to ask questions. If at any point during the presentation you have a question, please feel free to use the chat feature located in the lower left corner of the conference window. We'll do our best to answer your question at the end. And if we've got one that we think would be useful for everyone to hear, we'll leave that for the group and share it with the group. If we don't get to your questions during the webinar, we'll be sure to answer them after the webinar concludes. Today's presentation is broken into 4 sections. The first is simply about Modular, which I'll briefly cover. The remaining 3 represent the bulk of today's presentation and will be covered by Justin. First, a little bit about Modular Mining Systems. For those of you that do not know, Modular began in 1979 in Tucson, Arizona by creating the world's first fleet management system. You probably know it. It's called Dispatch. And to this day, some 33 years later, Dispatch stands as the mining industry's dominant FMS. Since that time, we've grown into a global company with offices in each of the world's major mining markets, shown in the slide. Part of the growth associated with Modular is the expansion of our products and services, shown here. Over time, we've grown from an FMS software company to one that provides the industry's most complete and trusted suite of mining solutions that we collectively call Intelamide. As you can see in the graphic, Intelamide spans the industry's major production segments, FMS, machine guidance with the Provision system, safety, network communications, support, consulting services, and last but certainly not least, the primary topic of today's webinar, maintenance via our leading MineCare system. MineCare, as I just mentioned, is a market-leading maintenance solution. Some of you might be wondering, well, what does that exactly mean? Well, this slide hopefully provides some detail. 2 out of 3 mines, or 66%, that use a real-time maintenance solution choose MineCare. Justin will provide some details a little later in the presentation about why that may be. Finally, to be a market leader, you obviously need customers. And at Modular, we're very fortunate to have the trust of some of our industry's most innovative and successful companies. Granted, this slide might be a bit gratuitous, but frankly, we're quite proud of our customer list. And if you see your company on this slide, we'd like to thank you for your business. With that, I will thank you for your time. If you have any questions, again, please feel free to use the chat feature in the lower left corner of the screen. With that said, I'll hand it over to Justin. Justin?
Thank you, Eric. Thanks for that good introduction about our company and product line. I want to also welcome everybody to our webinar. This is about gaining the benefits from condition-based monitoring. More specifically, we're going to discuss the benefits available to our users of the Modular MineCare system. As we start, there's some basic points about maintenance and condition-based monitoring that I want to discuss before we actually get into details about the system we provide. Capacity assurance is a term that is often used in both maintenance and reliability magazines and at conferences. What I take from capacity assurance is that this is basically a term that we could consider our tagline for what we're supposed to be doing as maintenance and reliability professionals. This term basically summarizes that our focus as these professionals should be on meeting the needs of our customers. And for maintenance, our customers is the operations group. We're here in these positions to provide equipment that operates to design, thus producing the required or desired production needs for our organization. So where do we start? When we're looking at improving our maintenance fundamentals, one extremely successful method is through condition-based monitoring. Condition-based monitoring must start with understanding what you want to address. Performing a failure modes and effects analysis, or FMEA, is the best way that I know in order to implement any condition-based monitoring or prediction model. When the what the FMEA instructs us to do is to identify all the systems and subsystems on board our equipment. After we go through and identify these components, we must brainstorm all their failure modes. This isn't as simple as engineer going in, sitting in their office, and filling out a spreadsheet. This is a process that's designed to bring a multitude of different perspectives together and workshop all the different failure modes that could potentially occur. I highly recommend this should also include working with the manufacturer whenever possible. It's great to understand many of the failure modes that they've already identified. So the key point is use all the resources you can in order to build this comprehensive list of failure modes. For each one of these failure modes, we then need to work out the consequences of that failure and the potential of that failure. One main reason that we need to include potential of failure is to allow us to understand the risk of this failure occurring. This can assist us as we build our CBM program to understand the priorities of implementation. Finally, we identify if there's any methods for prediction and how we could implement those methods. One other key concept that we must be aware of as we look at implementing improvements is where we stand today and what are our desired or acceptable ranges when working on improving maintenance processes or the availability of equipment. What I want to really emphasize here is that we can work extremely hard to gain a 5% increase in availability. But if we have to double our current overall cost in order to gain this, we have to know if this is acceptable. You can start by looking at your cost per ton and understanding how much maintenance practices add to this cost per ton. After implementing a tracking mechanism for cost, you can make your process improvements, let them stabilize and measure your results. And then you can ask your questions. Did I maintain the cost index in an acceptable range? Did my cost drop? Did it rise? All this tracking will help you demonstrate your results for the overall improvement to the organization. Another side benefit of this is if you actually implement processes or improvements that show to be either cost reductive or have no impact to cost, those can easily be implemented as best practices throughout your entire organization and sister sites. So I mentioned capacity assurance as the tagline for quality maintenance and engineering. As we bring in condition-based monitoring, we want to also identify what areas we're focused on for improvement. The areas we chose for this webinar, for example, are specific customer examples of improvement in availability, reducing costs, which ultimately leads to the organization an increase in production. With any implementation of new systems or technology, each organization has to know what potentials they may receive. We at Modular are extremely fortunate that we have customers that attend our user forums and discuss the strengths or struggles that they have had. It also allows them to work within our community of users to improve processes and share knowledge. Another nice thing that we have with such a large customer base is their willingness to share information publicly. This customer identified that when they were implementing the MineCare system, they wanted to focus on reducing maintenance cost and the downtime. They implemented a pretty robust cost tracking system to understand the overall impact of putting in their predictive models, identifying things before they actually failed. And because of this, they provided us the results from tracking these systems over the first 2 years of having the system implemented. Basically, if you look at the chart, over the 2 years of their implementation process, they were performing change management, focusing on continuous improvement. This organization was able to save over $2 million in their first 2 years. They've made additional improvements, and now they're now averaging saving over $50,000 per truck monitored in the MineCare system. All right, right now, if you would take a moment, I'd like to put up a quick poll question. If you'd take it and answer it, but while you're answering this question, I'd like you to consider when you're selecting a couple questions. One, have you performed a detailed failure mode analysis on this component? 2, how many documented failure modes have been identified? And 3, how many could be predicted with access to real-time sensor data? The more failure modes we understand the inputs to and build prediction models against, the closer we will actually come to capacity assurance. All right, so now we're going to get into the system. So what is MineCare? This is the major topic of this webinar, so we're going to spend the rest of the available time discussing the product that Modular has that's built to assist the maintenance improvements through condition-based monitoring. MineCare was introduced to mine maintenance groups back in 2004. The focus of this product was to provide key sensor data in real time back to the equipment experts. This allowed the experts to make intelligent decisions on the overall health of their equipment. The focus was to assist organizations in their move from a reactive culture to a proactive culture by getting work scheduled prior to failure. It connects a mobile computer to the onboard sensor systems. So whether people are interested in engine data, hydraulic information, tire temperature and pressure information, or even onboard oil analysis information. What Modular does is we build these interfaces to these specific data points from our mobile computer, and we transmit that data back in real time to the central system. This product, it came out on the market with several areas of focus to help with capacity assurance. Some of these areas of focus, are that we know that real-time data can assist in moving from a reactive organization to proactive. We also know that onboard sensor data can be collected and analyzed to help create user-defined alarm set points for allowing advanced warning of conditions to assist with the scheduling process. We also want to reduce the amount of time that's required to troubleshoot issues, and finally, the ultimate goal is to reduce the total number of alarms through predictive analysis and ease of diagnostics. I've got a couple scenarios that I'd like you guys to consider as you're looking at real-time maintenance systems. First, have you been out in the field and working on diagnosing a failure and noticed that several kind of operator alarms led to the premature failure. A real-time system increases the accountability on operators to use the equipment properly. Our customers have seen operator abuse immediately reduced upon implementing the MineCare system. Another scenario is how many times has an operator called maintenance to report an issue, and maintenance just tells them, I'll check on that later, keep running, it's not that critical. And then when you're going out and performing your root cause analysis, because this piece of equipment is broken down in the middle of the haul road, you find out that this has occurred. With the real-time maintenance system, we can immediately diagnose the issue and understand what the operator is seeing and what the criticality of the issue. The desire for this system has been and continues to be to take this raw data, convert it into useful information so that the experts can predict and prevent failures. So now the question we need to answer next is what is MineCare Standalone? Modular, we've released a version of our maintenance software to be used regardless of fleet management provider. Since 2004, MineCare has been deployed on the exact same hardware as the modular dispatch system. Now we've introduced a new headless hardware platform that will run MineCare with or without dispatch. It's basically our desire to implement this regardless if there's a competitor fleet management system or no fleet management system on site. Our PTX hub hardware will connect to the onboard interfaces. It'll transmit the real-time sensor data and alarm information back to the office application. So what does this product bring to the market? First, it's the independence of the fleet management system. As I just mentioned, we've decoupled this from our core product to allow additional customers out there to gain benefits. Next, it brings together the ability to centralize both alarms predefined by the manufacturer and the alarms that are created based on the logic implemented by the user. With these alarms, the user has corresponding sensor data captured through a snapshot or a trend feature that allows for automatic data collection. An example of this, we have a customer that implemented logic to identify injector issues prior to any OEM alarm being triggered. By implementing this logic using the raw sensor data, this customer was able to improve the overall process of injector replacements by scheduling them rather than waiting for the OEM alarm and having unscheduled repairs. The next main feature is the ability to stream sensor data in real time. This allows for the ease of diagnostics to perform some pre-PM. What a lot of customers will do is a week prior to the PM, they'll have a set of critical sensors that they'll monitor through the MineCare system, identify if there's any items that need to be added to the backlog or front log system during that scheduled downtime. And then also the collection of data for research is another point of the real-time monitoring. We also have the ability to create our automatic data collection by creating your own condition-based monitoring logic through the trending application for either research or the creation of user-defined alarms. And then the back end of our system, we use a standard Microsoft SQL Server along with Microsoft reporting services. That way it's a standard deployment, easy to create your own custom reports through the collected data. Now I want to talk briefly about the basics of implementing processes for improvement with the MineCare system. As we implement the real-time system, the first thing we immediately see is the overall health of the fleet being monitored, as shown through the active OEM alarms. These alarms will come into our event handling screen, which is our main screen for monitoring, diagnosing, and initiating any processes based off alarm conditions. One main feature of the system is the ability to configure the alarms based off the knowledge of the experts on site. So from these basic alarms being triggered, we want to start entering details about those alarms. So from the event details screen, we can see the information that we've entered about the events in fields for troubleshooting, for causes, or we can add hyperlinks in those fields to external documentation, websites, things like that. This is also where we will see the details about any sensor data that we captured automatically based off of the alarm. This is what we call our snapshot. So understanding how we got here, we first understood the health of our onboard systems by seeing all the current triggering OEM alarms. Second, we configured the alarms with processes to do automatic data collection and put procedures in with them. Now we're at the point of having this data be collected automatically. This data comes in showing what occurred before and after the timestamp of our alarm condition. This allows us to start understanding the conditions leading up to and what happens after the alarm is triggered. It's important to collect this data and start understanding and building methods of predicting these conditions so that we can prevent these alarms that indicate that a failure is about to occur or has occurred. So the final step of this CBM process is to go into our trending application. This is extremely critical because our ability to enter condition-based monitoring logic in the trending tool will help us predict those failures. And why do we do this? So most reliability professionals have probably seen this slide over a few thousand times, but with all condition-based monitoring programs, the focus of MineCare is to help us move back on the PF curve. This curve represents the time that it takes for a failure to occur and our earliest potential indicators prior to the failure. In line with this curve are some recommendations on how to implement strategies to address these failures. One common way is to implement preventive maintenance. This helps move us farther back on the curve, but condition-based monitoring, another predictive science, allows us to move even farther back. Understanding the potentials of the issues that are out there and that are causing our unscheduled downtime. All right, the last topic I want to quickly cover is a couple examples of how customers have improved availability and reduced cost. I won't spend too much time on these. They are available on our website, and you're also able to contact myself or any Modular representative to get the more detailed information about these case studies. The first case study I've got mentioned during this presentation, the customer needed a method to address injector failures, and they needed a process that would allow them to schedule the repairs rather than having unscheduled repairs and inconsistent policies around whether or not to bring the equipment in. This was the case study I quickly mentioned earlier in the presentation. So what they decided to implement was monitoring the delta between the bank temperatures and they wanted to monitor at a greater delta than the OEM recommended. So the engineers would basically capture this data through the trending and then review the captured data to understand the severity. from there, they would produce a report to give to the maintenance planners to schedule based off of priority. This process resulted in an overall improvement of availability by 4%. This group, because of this process, they were able to move it from only monitoring on trucks to monitoring on all their equipment running diesel engines. They were also able to reduce the amount of time required to replace the injectors. That part, as far as reducing the amount of time, there's a nice write-up about how they did that, or you can contact us. It's really an impressive process that they implemented. The next case study was an opportunity for a customer to use our automatic data collection through trending to understand how much fuel was being used during a common dumping technique by the operators. Basically, when dumping a large truck, it automatically raises the RPM up to about 1,500 RPMs. And then it was believed by the operators that if they push down on the throttle, raise the RPMs up to about 1,900, that the bed would lift quicker and save time at the dump. So this organization wanted to understand if it did increase the amount of time dumping or decrease the amount of time dumping, and what was the cost of the fuel. So they set up two sample sets. One set of the trucks was using the standard dumping technique, while the second set was doing the high RPM method. This customer identified that at this high RPM, it did not lift the bed any faster than the standard operation. They also calculated, based on the difference in the amount of fuel used between 1,500 and 1,900 RPMs, that by eliminating this technique, they could save approximately $300,000 plus per year in fuel savings. I think we should continue to look at the ultimate goal of capacity assurance with process improvements that will hopefully reduce cost, improve our availability, and lead to the increased production or efficiency gains in production. So I want to end this webinar by thanking everybody for attending. The discussion on MineCare Standalone and maintenance techniques. I also want to make sure that we look at continuing to improve the process in mine maintenance. At this time, if there's any questions that you want to send in, I'll gladly answer.
Thanks, Justin. And just a reminder to those of you on the conference call, any questions that come up after the webinar, feel free to send them to products@mmsi.com, as shown there on the screen. Of course, you can always peruse some of our literature and other materials at our website, modularmining.com. I know we've gone over the allotted time, but we do have a couple questions. If you'll bear with us, we'll see if we can't get those answered, because I think they're useful and relevant to everyone on. The first is, how does the standalone version of MineCare work differently to the standard version of MineCare?
As far as the difference between the two, upon install, the difference is that we use a different hardware. So versus a standard deployment of MineCare with dispatch, we use an onboard computer that has a screen for operator interaction. When we install MineCare Standalone, it's a headless device, has no screen, can be installed anywhere to connect to the onboard sensors. The differences on the office side are, again, related to the dispatch integration. So we have an application in MineCare called Time Tracking, which allows you to see the status changes of equipment from the dispatch system and track the amount of time spent during those maintenance downtimes. So those are really the only two major differences between a standard and standalone deployment.
Great. Thank you, Justin. One final question, and then we'll wrap it up for this webinar. How does Standalone, the standalone edition of MineCare, fit into a greenfield mine site?
Well, for me, from my experience working in the copper mines and trying to change the culture, I think a MineCare solution, similar solutions, are excellent to go in at a greenfield site. I think it's much more difficult to change culture and change processes that have been embedded in the organization for many years. Bringing in a system right away and kind of orchestrating this culture of continuous improvement and condition-based monitoring, I think is extremely beneficial to any organization looking at starting up.
Excellent. Thanks again, Justin. And thanks to everyone for joining us today. I know we went a little over, but we appreciate your time. Those of you on the call today and anyone who's registered will receive a survey at the end of the webinar, and we'll also send you a follow-up link to the recording of the webinar. If you've got additional colleagues you'd like to send this to, please do. Thanks again for your time. We hope to see you soon.